Okay, so let's recap. We have a triangle. Okay, it has to be a right triangle, of course. Let's say that we have theta over here. So now, let's say we have A here, B here, C here. Then, for sine theta, looking at the triangle, we see that, so for sine theta, it's going to be opposite over hypotenuse. So this angle is right here. So the opposite side is going to be A. And of course, the hypotenuse here is C. So sine theta in this case is going to be A over C, opposite over hypotenuse. And then for cosine theta, it's going to be adjacent over hypotenuse. So this side is adjacent to the angle. So we're going to be doing B over C. And then for tangent theta, it's going to be opposite over adjacent. So opposite over adjacent. So it's going to be A over B. Okay. So that's how these functions work. So we use these trig functions to calculate pretty much the ratio of each side. So whenever you're given an angle, so I guess a good example would be like, let's say like, a good example would be, let's say, this could be 6, this could be 3, this could be, and we want to know what x is. And we have 30 degrees here. Oh shoot. I forgot I made this word public, but it's okay. So then in that case, you can literally just use any trig function here. So let's say, I don't know, let's say you could use tangent. You could use tangent, right? Let's say if you decide to use tangent, then you would do tangent of 30 degrees. And this would be opposite over adjacent. So opposite of this angle is 3. And then adjacent would be, adjacent to the angle would be x here, right? So now you can solve this side, find this side, by solving for x. So in this case, x would equal, well, we could just reciprocate. So this would be x equal to 3 tangent of 30 degrees. And then you just put that into your calculator, make sure your calculator is in degrees, and you should get something like x is equal to, what would it be, 3 root 3? Something like that. 3 square root of 3. I don't know the decimal point for that, but something along those lines. You can use sine theta, that would work. Wait, no, I lied. No, you cannot use sine theta. You cannot use sine theta. Sine theta will not give you this x because in sine theta, there is no adjacent side. X is on the adjacent side, so you can either use tan theta or cosine theta because it has adjacent. Sine theta does not have adjacent, so if you use sine theta, you're just going to be computing these two numbers, not this side. Yeah, that's pretty much it. So that's for that concept. Let me go ahead and clear the whiteboard. It's not even a whiteboard, it's a blackboard actually. Now let's say we have to find the angle. Let's say we have to find the angle now. So now this would be, let's say, 5, 12, 13, right? Now, how do we find the angle here? So now, again, you can use sine theta, cosine theta, or tangent theta. Of course, let's say you're more comfortable with just using tangent theta because it's fun. we could go ahead and use tangent theta. Tangent theta is opposite over adjacent. So opposite to the angle is 5. Adjacent to the angle is 12 here. So to find the angle, we would do the inverse tangent of 5 over 12. And that would be your answer. Just plug that into your calculator, and then that should give you your angle theta. You can also use sine as well. Definitely, you can use sine theta, right? But sine theta, of course, sine theta is opposite over hypotenuse. So the side that's opposite to the angle is 5, and the hypotenuse is 13. And so your theta would be the inverse sine of 5 over 13. And this should give you the same answer as this. So that should work. Let's see. So that's that. So that's how you find the angle of a triangle. We can recap on special triangles. There are 2 special triangles that you mainly just going to be learning about. There's the 45 degree, the 45-45, right? A 45-45 triangle. The 45-45 triangle is the only isosceles right triangle. It is the only isosceles right triangle, right? And then for a 45-45 triangle, if these sides is 1 and this side is 1, then this side would be square root of 2, okay? And if you have a 45-45 triangle, and if this side is 1, then pretty much what that does is that makes everything divide by the square root of 2. So this would be 1 over root 2, and this would be 1 over root 2. Okay. Sometimes the textbook would rewrite it as root 2 over 2, but this is the same thing as this number because if I go ahead, you can let me erase this. So this number is the same thing as this number because if I multiply it by root 2 over root 2, right, then 1 times root 2 is root 2. Root 2 times root 2 is just 2. So they're the same number. Okay. So that's the 45-45 triangle. So let's go ahead, erase that. Okay. The next special right triangle is the 30, 60, 90 triangle. This is 60 degrees, and this is 30 degrees. Okay. The reason why this is a special triangle is because it is actually, if I drew another of the same triangle, just like a half, then what this is this is actually an equilateral triangle. You get an equilateral triangle because this is 60 degrees, this is 60 degrees, and this is 60 degrees, right? So this is just a half of an equilateral triangle. So let me erase that. So now that's why when this is 2, this is 1. Because it's a half of an equilateral triangle. So this is 2, this is 1. And then the height right here, this is equal to the square root of 3. Okay. If you don't know, or if you don't remember, again, you could just use the Pythagorean theorem, right? 1 square plus whatever b square is equal to 2 square. You're going to essentially get into 3 b is equal to square root of 3. So this is square root of 3. So in case if you can't remember that, you can always just do Pythagorean theorem. Same goes for the 45 triangle. Okay. And if you get, let's say, another 60, 30, right? And let's say if this was 1, then this would be 1/2. And this would be square root of 3 over 2. Because you're dividing everything by 2, of course. Okay? So that's the two special right triangles. All right, now for the angle positions, we're already familiar with that, right? For the angle positions, I'm going to draw a polar graph. Okay, this side, we start 0 degrees on this side. If I have my terminal here, right? So then this is this terminal arm, then this is 45 degrees, right? If I have my terminal here, then this is like 180 plus 45. 180 plus 45. That's like 225 degrees. So all the way to here. So that's 225 degrees. Right? Okay. If my terminal was, let's say, we can go around, then this is what's called 360 degrees, which again, we're already familiar. And now let's say we're given a problem. Let's say what is negative 100 degrees? What is the reference angle of negative 100 degrees? Reference angle is pretty much an angle from 0 to 360. So to find the reference angle of negative 100 degrees, we just, well, because it's a negative, we can add it, 360. So our reference angle would be 260 degrees, which is, I don't know, 180, 270. So 260 would be somewhere here, which is the same thing as negative 100 degrees. So again, so the reference angle to negative 100 degrees is 260 degrees. And if we want to compare these two angles, we say these are coterminal to each other. So negative 100 degrees and 260 degrees are coterminal. Okay. Another example is, let's say, 500 degrees. What is the reference angle to 500 degrees? So now we subtract 360. So now we subtract 360, and we will get 140 degrees. So 140 degrees, that is somewhere here. That's somewhere here. So 140 degrees is the reference angle to 500 degrees. And we also say that 140 degrees and 500 degrees are coterminal to each other. Okay? So that's just some math vocabulary. Okay, so that's it. Next thing is quadrants. So we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right, so if we just think about the xy points, right? This would be positive here, right? Then this would be negative positive here. This would be negative here. And this would be positive negative here. with using this concept. We have this graph here. All right, so we're gonna recap. So we're gonna have a terminal arm here. Okay. Then we use this blue pen. Right. So we have this point here, which is for some x, y point. Then x is here, y is here, and this is called r, the radius. And this is the angle here. And so now sine theta is going to be, so sine theta here is opposite to hypotenuse. So it's y over r. Cosine theta is going to be x. X is adjacent to the angle. So it's x over r. Tangent theta is going to be opposite over adjacent, so y over x. Okay, so that's how we get this. So again, x is here, y is here, and the radius is right here to r. Okay. So now, going back to here, in quadrant 1, every trig function is positive, right? So in quadrant 2, x is negative. So the only thing that's positive is the one that does not have x. So sine theta is going to be positive in quadrant 2. In quadrant 3, tangent theta is going to be positive. Okay? Because x and y are negative, but a negative divided by a negative is going to be positive. So tangent theta is going to be positive only in quadrant 3 only tangent theta is positive in quadrant 3. In quadrant 4, y is negative. So anything that has y is going to be negative. In this case, cosine theta is the only trig function that's going to be positive in quadrant 4. So, writing this down, in quadrant 1, so we can just go ahead and write this down. In quadrant 1, all are positive. Okay. In quadrant 2, let's see, x is negative, so sine theta, so sine is positive. All right. Quadrant 3, tangent is positive because negative and negative. And in quadrant 4, cosine is positive. All right. So that's that. So that's this concept here. All right, now I'm going to go ahead and erase everything. So this is so we call this a unit circle here. And we start here as 0. This here is 90 degrees, etc. So we assume this to be radius of 1. So this circle, where is that blue marker? So this circle here, so this is radius of 1. So if I were to draw a point right here, so this point here is 1 to 0. This point here is 0 to 1. This point here is -1 to 0. And this point here, if I cannot, why is it not? Okay. That point right there is 0 to -1. Right. So like it's like in an XY plane, this would be 0, 1, this would be 0 to -1. So again, the radius is 1. So then here, if I want to know the point here, so let's say like if the angle is 45 degrees, then what is the coordinate here? Well, this is it's that 45 angle, right? So we know that this is 45, this is a 45, 90 triangle. So if the radius is 1, then the sides here is going to be square root of 2 over 2, and this is going to be square root of 2 over 2. So this coordinate here is going to be square root of 2 over 2 and square root of 2 over 2. So that's how you find the coordinate here. So if there's going to be a trig equation like let's say like sine theta is equal to square root of 2 over 2, right? Then we know that, well, be careful because there's actually more than one solution here. So theta is equal to what? Well, we know that it's going to be 45 degrees because we know sine 45 degrees is square root 2 over 2, right? So theta is going to be, it's going to be pi, not pi, blah, 45 degrees. Okay, but this is not the only solution. Sine here is also root 2 over 2 because this is square root of 2, this is negative, and then root 2 over 2 right here. So sine here, so usually the y is like our sine, our x is like the cosine. So because like we set the radius to 1, so if you think about it like this, like sine of 45 degrees, right? We recap that this is like y over r. R is 1. So because r is 1, this is just y. So that's why we only look at the y portion here for sine theta. And then if it was for cosine, right? If it was for cosine theta, we know that this is x over r. And if we set r equal to 1, then this is just x. Because again, the radius is 1. So that's why we mainly just focus on x or y when we look at cosine or sine. So for here, for sine 45 degrees, we're only going to look at square root of 2. In this case, this angle has square root of 2, and this angle has square root of 2 for sine. And so we have 45 and 135 degrees as our answer. In fact, there's infinitely many more answers. It's literally any degree, 45 degrees plus plus 90? No, I'm sorry. No. It's there's like a system. There's a system. But it's 45 degrees, 135 degrees, and it's literally like any 45 degrees plus 360 degrees n, and then 135 degrees plus 360 degree times n for any n whole number. I'm sorry, not whole. It doesn't have to be positive. It could be literally a negative number too, right? -1, 0, 1, 2, for whatever n. So this is actually the solution, but usually we'll mainly just take these two solutions, and we're technically good to go. All right, Jesus Christ. I think that's about what you guys are at. All right, that's it.